At the eastern edge of the Karakoram Range lies an environment defined entirely by sheer verticality and glacial valleys. This is an extreme evolutionary filter. The Karakoram Wildlife Sanctuary occupies a highly sensitive geopolitical position. Spanning roughly 5,000 square kilometers within Ladakh, it shares immediate, contested international borders with the Tibet Autonomous Region to the north and east, and Gilgit-Baltistan to the west. Sitting in the deep rain shadow of the greater Himalayas, the sanctuary receives less than 100 millimeters of annual precipitation. The climatological regime swings violently from intense high-altitude solar radiation to a blinding whiteout, where ambient temperatures routinely plummet to -40 degrees Celsius. Above 5,000 meters, atmospheric hypoxia compounds the thermal stress. The partial pressure of oxygen is a fraction of what exists at sea level, presenting a strict physiological barrier to standard mammalian and avian survival. The flora and fauna endemic to this cold desert have evolved highly specialized traits to endure the hypoxia and the freezing temperatures. They synthesize concentrated pharmacological compounds and grow incredibly dense thermal wool. Yet these exact evolutionary solutions have rendered them highly lucrative targets for anthropogenic extraction. To understand how global markets and border militarization are threatening to collapse this biome, we have to deconstruct the ecosystem from its bedrock constraints up to its apex predators. The baseline parameters for life are set by the geomorphology of the Chiru watershed. Intense tectonic uplift and glacial carving dictate the hydrology. Deep, narrow transverse ravines are sliced by glacial meltwaters, leaving intermontane valleys dominated by fragmented scree slopes and bedrock cliffs. Rivers like the Nubra and the Shyok wind directly through this inhospitable lithology, acting as the sole hydrological lifelines across a barren plateau. Because the terrain relies entirely on winter snow, the growing season is severely abbreviated. The sandy soils remain heavily nutrient deficient year-round. These harsh lithological and climatological realities mandate a strict spatial distribution for any primary producers attempting to take root in the watershed. The ecological marginality of the region forces local flora to synthesize highly concentrated secondary metabolites to survive the cold and poor soil. This table maps the altitudinal stratification of vegetation. At lower riverbank elevations, sea buckthorn thickets serve as critical soil stabilizers. Pushing into treeless alpine pastures above 4,500 meters, endemic herbs like Dactyloryza hadagira cluster in specific microclimates, entering critically endangered status. The traditional Amchi medical system relies entirely on these alpine botanicals. Practitioners formulate treatments by precisely combining and handling the harvested plant material. For generations, extraction was balanced by village agriculture. Today, adult men are transitioning into military logistics or wage labor for organizations building border infrastructure. Without reliable agricultural income, marginalized populations are turning to the intensive wild harvesting of lucrative medicinal plants, stripping the fragile alpine topsoil. The faunal web operates under the same extreme scarcity. To survive on sparse biomass, high-altitude ungulates utilize strict spatial partitioning to avoid competing for calories. Species like the blue sheep have evolved for precipitous inclines, using sheer cliffs and rocky crags as an immediate vertical refuge from predators. Conversely, the endangered Tibetan argali is confined to open grassy fields. It relies entirely on sustained cursorial speed to outrun threats. This lack of climbing adaptations makes the species uniquely vulnerable to physical fragmentation of its habitat. Pushing the limits of mammalian survival, the massive wild yak grazes exclusively in the highest oxygen-deprived extremes, navigating desolate patches of frozen pasture. At the very top of this web sits the snow leopard. Because prey density is so low, this felid requires an exceptionally massive home range.
Those massive hunting ranges inevitably intersect with transhuman herding routes. The resulting depredation costs pastoral households an average of 6 livestock animals a year. This forces herders to deploy guard dogs and professional hunters to protect their remaining economic assets. Within this web exists a highly specialized bovid, the Tibetan antelope, or Chiru. It is endemic exclusively to the Tibetan Plateau and its peripheries. To endure the Leeville -40-degree winters, the Chiru evolved the thickest and finest woolly underfleece of any mammal on Earth. Despite spanning vast, fractured geographic ranges, the global Chiru population functions genetically as a single panmictic unit, maintaining a healthy shared gene pool. This genetic data, utilizing mitochondrial DNA markers, proves the mechanism. The large negative values for Fu's Fs and Tajima's D across different regional cohorts indicate a massive, ongoing degree of genetic exchange, allowing the species to recover from historical bottlenecks. But the biological mechanism required to achieve this genetic mixing is physiologically brutal. Pregnant females endure starvation, blinding blizzards, and extreme exhaustion to reach hyper-elevated calving grounds. Evolutionary logic dictates this synchronized migration because those desolate, frozen destination zones lack terrestrial macropredators. However, this predictable geographical bottleneck provides organized poaching syndicates with an exact time and place to intercept the herds. The Chiru's thermal underfleece is known in international markets as Shahtoosh, the king of wools. It is renowned as the finest, lightest, and warmest natural fiber available to the high society fashion industry. Unlike pashmina goats, the Chiru cannot be sheared. The animal must be slaughtered to harvest the wool. Producing a single, standard-size shawl requires the execution of 3 to 5 adult antelopes. This map details the clandestine supply chain. The raw wool is harvested from slaughtered herds on the high steppes of China, smuggled south through porous bottlenecks at the Indo-Nepal border, and funneled into Jammu and Kashmir, where specialized clans spend years hand-weaving the fibers. Exhaustive surveys across Ladakh reveal active local complicity in this trade. The poaching syndicates exploiting the Chiru migration routes are concurrently trafficking other globally protected apex predators out of the sanctuary. As Western fashion markets drove the black market price of a single shawl to $20,000, commercial poaching operations scaled up their weaponry. By the late 1990s, a population that once numbered in the millions had collapsed to roughly 70,000 individuals. The speed of the slaughter forced an absolute international trade ban. CITES established a strict Appendix 1 classification, legally walling off the Tibetan antelope from global commerce. To enforce this ban, the Wrap Up the Trade campaign divided the geographic labor. The International Fund for Animal Welfare systematically targeted Western consumer demand and financed forestry police in China, while the Wildlife Trust of India worked to dismantle the smuggling routes and manufacturing hubs within domestic borders. Yet enforcement in the Karakoram remains compromised by intense regional militarization. Heavy, ongoing troop movements through these contested, high-altitude borderlands severely disrupt the grazing grounds and complicate local ecological surveillance. As the Border Roads Organization carves deeper into the rock to secure the frontier, the newly paved infrastructure inadvertently provides poachers with faster, smoother logistics to extract raw materials. The flora and fauna of the Karakoram survived for millennia precisely because the extreme hypoxia and freezing temperatures filtered human presence out. Today, those exact physiological adaptations, when forced into contact with globalized luxury markets and heavily militarized borders, are the direct mechanics driving the ecosystem toward collapse.